So I hope you're seeing my screen.
Yes.
Okay, so hi, I'm Mike Tuts from Columbia. I'm going to report on the Open Symposium European Strategy for Particle Physics, and this is going to be with regard to the 2026 update. So first, a little bit background and context. For the European Strategy for Particle Physics, it's sort of the equivalent of our P5 process as input for the long-term future of the field. And in the case of the European strategy, started in 2006. I'm going to focus on this last piece, which is the 2026 update. I'll just mention the 2020 update, which led to what's called the FCC feasibility study. And so this update is the recommendations for the next flagship project at CERN, the preferred collider option, and possible prioritized alternatives and areas of priority for exploration complementary to colliders. And the Venice meeting was the equivalent of our SNOMAS process to provide community input. It's mandated by the CERN Council, and the European Strategy Group, or the ESG, develops the recommendations, which are then submitted to the Council for an update of the actual European strategy. And the inputs are the type that you can see here. This timeline you may have seen quite often. I just point out that the Open Symposium, the Venice Symposium, took place from June 23 to June 27 of this year. And you see the next major milestones, which end then with ultimately this draft document prepared by the ESG group goes to the council, and they will then ultimately update the strategy. So the process I'm not going to dwell on. There was a talk by Mont sometime back in February, which I think some of you were probably present at. I've put some of that information in the backup slides here, and also a link to the full talk at this point. So let me just summarize very briefly the main elements of these groups. There is of the European Strategy Group, and it has the following components. There's a secretariat. Carl Jacobs is chair, and then chairs of various groups involved are also members of this secretariat. They organize and run the ESPP process. There is a physics preparatory group, the PPG, that collects input from the community, organizes the open symposium, ultimately prepares a briefing book as input to the ESG. There's a U.S. representative on that, who's Anadi Canepa. There are a number of working groups that I've indicated over here. The European Strategy Group, the ESG, is the body then that prepares the strategy document for the council. It has one U.S. representative, that's me, and it has a number of working groups, which I'll mention a little bit later on. In the one for the national input, Anadi serves on that, and I serve on the working group 2, which is for the project comparison. Another piece of the pie of the process is that ECFA generated a number of questions which are aimed for the national inputs to provide input, and I'll show you that when we get to the working groups and what they're doing. So here's some brief description of what happened at the Venice Symposium. There were some 263 contributions that were received by the deadline of the end of March, and a few post-deadlines contributions as well. If you want to see the full list of those contributions and links to the actual contributions, you can go to this Indico site over here. There were something like 71 parallel talks on the first day, and then a total of around 52 plenary talks over the other ensuing days, and I've showed you the number of talks in each of those sessions. And here is a little bit of a breakdown of where those papers and where those inputs fall in terms of what they address. There is a lot of ground to cover, and so I'm going to be rather brief, and I've tried to put links everywhere so that, for example, if there are links to the backup slides, you can go there and then return back over here. So on the opening plenary, there's started with a talk from Fabiola Gianotti, the DG of CERN, on the implementation of the 2020 update to the European strategy. You see the words associated with that. asking to investigate the technical and financial feasibility of a future hadron collider at CERN with center of mass energy at least 100 TeV and with an electron, positron, Higgs, and electroweak factory as a possible first stage. That then led to what's called the FCC feasibility study that was delivered in March of 2025. It's a huge document. There are a number of chapters. It's 1,200 pages, covers a lot of everything that you would need to know in terms of the FCC EE and the FCC HH. I make just one comment over here with which Fabiola emphasized, which was that as you head into the future like this, it's very important still to maintain the focal point on the high luminosity upgrade, its successful completion and use, because that's going to be one of the important aspects in terms as we head into the future. She talked about many aspects that I've listed over here. One aspect, of course, is the cost. You can see a table over here for the FCCEE, total of around 15 billion Swiss francs, so a large number. And here you have, there are ongoing discussions now with the council, but here are some discussion of how one would address that funding. It would cover more than 50% of the FCC coming from the CERN budget, and then other external contributions that you see listed over here. The other plenary opening talk was on physics given by Eric Lehnen on outstanding questions in particle physics. I've just captured a few of the transparencies that he showed. As he said, he was very enthusiastic about the possibilities here. For example, he identified the closure test of the standard model, so a plot of the W mass versus the top mass, looking at the Higgs potential and understanding what that really looks like, looking for new physics and the sensitivity that you have using effective field theories, and noting also that as the experimental results improve in precision, the theoretical precision will also have to improve to keep up with it. And I have some comments over here that he said, but basically quite enthusiastic and noting that a bright future is possible. And so let's get going on it. Now, it's an impossible task to even summarize not only the parallel talks, but of course the plenary talks. There were 52 of them. So as I said, what I've tried to do is give you, you'll find underlined words which take you to a link either to the actual talk itself at the Venice Symposium, or in some cases, what I'll try and do is provide a brief summary of the conclusion slides for the talks to give you a flavor of those talks. Even that isn't possible to achieve in the 20 minutes. So I have put some internal links in here where you can go to those one-page summary talks. In general, then it's going to be the job of the PPG and the ESG to evaluate and compare the proposed projects and do that on an equal footing. A lot of that work has already begun, and a lot begins now in earnest after this input from the symposium is available.
Would it help me if I move my car?
Somebody has got their microphone on.
Okay.
In that spirit,
Or
what follows is a whirlwind tour. I'll be skipping a lot, and I'll try and show you the places where you can go and see a little bit more information. So for example, if computing, I'm not going to mention, of course, it's obviously important, but if you click there, you'll see that you go to a computing page and you can come back to where you started if you want to look at some of those in a bit more detail. So these I am not going to talk about. Of course, everything is important about communication across the spectrum of society, about computing. That's obviously challenging, but indicated that's achievable, particularly if you have common projects where you can use your manpower effectively and then continue with R&D support. On accelerator technologies, I'll say a little bit about that, but I won't talk about a couple of talks that were given about R&D progress and challenges to high luminosity. Those you can look at over here. So let me start with the large-scale accelerator projects that were talked about. And that is starting with the FCCEE, a talk by Michael Benedict. Even when I show you their sort of summary conclusion bullets, there isn't enough time to go through all of those. So I've tried to highlight in yellow, picking some that I think are relevant to this discussion. So here you see the FCC-EE, a cartoon of that, an E plus E minus circular collider. What he notes is the FCC-EE design level now enables moving towards a technical design and the prototyping phase, and it's well aligned with the overall schedule heading towards a preparation of input for a potential project decision by 2028 by the CERN Council. Frank Zimmerman talked about FCC-HH as FCC's second stage and possibly based on things such as high temperature superconducting magnets, and that could start operation in around 2074. There are other options that are mentioned over here as well, but again, in the interest of time, I will move on. The other projects mentioned are the linear collider at CERN. This was talk given by Steiner Stapnes. Again, you see a table over here for LCF and for CLIC with the projected costs, and you see two cartoons for the LCF and for CLIC over here on the right. Again, I won't even talk about all of the summary bullets, but just pick a few. He notes that a linear collider as a stage project can be implemented at the 7 to 9 billion Swiss franc level for the first stage, one of course can upgrade energies. And then he notes that a 3-year program is suggested to establish the linear collider baseline, building on and extending existing international collaborative R&D. There are some what we are calling intermediate projects, and those are intermediate in the sense that they would have to be a step towards a flagship project. So one was LEP3, which was presented by Jim Verdi. So it's reusing the LHC tunnel. And this was in the spirit, as he says over here in his bullets, that if the FCC is deemed to be not feasible financially, then going this intermediate route over here with a LEP3 provides what he says over here, leaves room both in terms of time, budget, and resources for further development of what he calls, and this is his emphasis, the machine that can then directly probe at these higher energies. So it is intermediate as a step. Another possibility would be LHEC, that was presented by Jürgen Dont, and that's a high energy, high luminosity electron-proton collider at the LHC. As he says here, an impactful alternative collider with excellent results in the Higgs electroweak top QCD. And with, what he says, is an interesting timeline. And you see it, the cartoon of it over here. This is an electron with energy recycling LINAC and with 50 GeV electrons and ultimately EP collisions at over 1 TeV. Next is the muon collider that was presented by Daniel Schult. And he focused on the excellent technical progress that had been made and a number of review committees that have weighed in on the project. And you see that he emphasized then this most recent review from their International Advisory Committee, finding significant progress, marked improvement, robustness of the quality of the studies, noting that all major technical challenges are being actively tackled, and that it's critical for launching and supporting a cooling demonstrator and test stands as soon as possible. Jenny List talked about linear collider vision. I won't emphasize it here. A number of areas where she indicated decisive advantages in particle physics, strategically and technologically, and pointed out that there are two, for example, examples of where one might place such a muon collider at CERN or at Fermilab. Then there were 3 talks on the international status, so of China, Japan, and the US. On the status for China, that was presented by Yifeng Wang. Again, I just go to my yellow highlights over here. In terms of the accelerator, he indicated it was ready for construction on the scale of approximately 2 years. For the detector, he said a TDR is under preparation now to be completed by the middle of this year for a proposal for the 15th 5-year plan presented to the Chinese government. For Japan, again, there was a lot of what's going on in Japan, but focusing on the ILC, these groups over here collaborating tightly to make leading efforts to realize the ILC as a global project. And part of that effort includes the so-called ILC Technology Network, ITN, which is a number of labs, which is ongoing and providing for open discussion on global collaboration. And he identified a number of issues that need to be considered for the overall timescale of the ILC. The US status was provided by Hitoshi Murayama. Again, when you see these links, these are links to the actual document where you can go. And he spoke about the P5 recommendations, so essentially the DPF input, development since P5, in particular national input from the Higgs Factory Coordination Consortium, muon colliders, 10 TeV Wakefield collider design, DUNE, and where the US inputs were in a repository that DPF has created. What you see over here, again, when you see the hashtag number, that's the reference to the Venice number of the document. But I'm not going to dwell on this at all because what you see in red here is a reference to the presentations that are being done today. So a lot of this input that Hitoshi talked about is presented individually by Tor on the Higgs Factory, muon collider from TOVA, the Wakefield collider from Spencer, and the National Academies report from Maria. So I will leave it to them to speak to those in more detail. So now let me go through some of the other plenary talks. There was one on the challenges for high luminosity by Gianluigi Arduini. Again, he has a number of points that he ends with, but let me just identify a few in the interest of time. He notes for circular colliders offer the possibility to serve more experiments and more flexibility on the operation at different energies at high luminosity, but noted, of course, there are issues in terms of beam and intensity effects, which are challenging, but there is indeed extensive experience in this area. For linear colliders, he noted they can operate at higher energies, but still limited at around the TeV range, and they rely on sophisticated feedback and feed forwards as demonstrated by SLC. He notes the positron production is challenging, particularly for the LCF, and on the other hand, that they can deliver polarized beams, at least for the electrons. Going further into the future, then the next generation high-energy hadron collider challenges are mostly technological and related to high field magnets, cryogenics, and vacuum. And for muon colliders, he notes that it could be an option for achieving high-energy lepton collisions, but are not at the level of maturity of the other proposals at present. So then there were a number of physics plenaries, and again, I cannot do justice to that for the interest of time. So what I'm going to do is I picked a couple for BSM and for dark sector. The others which
Mike, I hate to break in, but you got about 1 minute left.
Okay. So I will very quickly try and go through those. For BSM physics, there were a number of questions that were raised. Fabio Maltoni noted that they don't have hard theoretical arguments, but have fundamental, it's necessary to address the open fundamental issues that you see there. On the experimental side, Rebecca Gonzalez Suarez noted the interplay between indirect and high precision measurements in the electroweak sector versus direct new physics from a wide range of masses and computing scales. Similarly, for the dark sector, there were these talks over here. Again, as Heidi is pushing me to finish, Sally is pushing me to finish, let me continue on. For detector technologies, there were questions of what are the future projects that drive instrumentation development, what technologies are required for the timescale, who will work on the instrumentation. And then a program that ECFA produces showing you various R&D areas, which you see in this cartoon over here. From the ESG working groups, again, I can't do the same thing of showing you what all of them are. There are important roles over here. I'll just show you two. One is national inputs. That was presented by Cal and Alexa. There were these questions that ECFA produced over here, and if you want to see more of the results, you just click on these and you can go to those. The national inputs from the US were from the HFCC and from the DPF, and again, if you want to click for more details, you can see it here. And the takeaway that you have here is that there was overwhelming support, and you see the breakdown here by member states, associate member states, and non-member states in support of the FCC program. For the US, we noted that its support for the FCC-EE in particular. For the working group TA, which is a project comparison, that was also done by our Gianluigi Arduini. That's working group 2A, looked at a number of colliders. They'd had already a document where they looked at the metrics for comparison, but the plan now is to review those cost estimates and associated uncertainties in that report, which were inputs from the proponents from a panel of experts. So that will be going on. The closeout was from Carl Jacobs, and you see that over here. I took this slide from him because he shows you what the leading projects are for the flagship program, but then shows the path forward to the future, depending on where you start and how you get to the future over here and what R&D will need to be done. He also showed a cost estimate for the various projects. Again, I leave that for your perusal. And he had some final words, which are, let me just read the three main bullets, that over the past years, very significant progress has been made towards a flagship project, and he indicates what they are. Discussions of prioritization of alternative options are ongoing, and keeping, of course, a strong complementary physics program beyond colliders is essential. And then what are the next steps for the ESG? It's releasing the briefing book on September 30th. Then this working group 2 about the flagship projects will release its major findings around mid-October. That will allow an opportunity for the national communities again to weigh in based on this information in a deadline of November 14th. So let me end there. And as I say, there's a lot of backup material. Sorry for the rushed presentation.
Thanks very much, Mike. You got one question during your talk. I don't know if you received any other questions through
No,
any
I
other
did not.
channels. So, yeah, so the question you have from Alexei Petrov is, what was the European view on participating in flavor accelerator facilities, such as KEKB in Japan and the Super Tau Charm Factory in China?
So there is, let me see if I can show you this working group. Sorry, there was so much. One of the working groups addressed the question of what should Europe continue to participate in. And I have, can you, I guess you're seeing my screen, right? So you're seeing this in small. Is that too small to see? So this was a working group 4, which was talking about relations with other fields of physics. And again, I've just highlighted this bullet of consensus, namely based on the majority of national inputs and various other groups in Europe on astrophysics and nuclear physics. And it said existing non-collider experiments at CERN should be supported as long as they don't take too many resources away, but CERN should not engage in additional non-particle physics experimental and/or hardware activities unless they have significant added value for its main mission to carry out accelerator-based research as specified by the CERN convention. And again, there are many other inputs in this area.
Yeah, we also have a question from Brendan Bullard at it was a pre-question from Brendan Bullard at Slack.
Yeah. Okay. Sorry.
Yeah, I can read that one. Is that the U.S. community has a wide breadth and depth of expertise that will enable strong contribution to the next generation machine and experiments at CERN. But what are the unique capabilities or R&D initiatives that the U.S. is best positioned to lead for these efforts?
So I added a couple of slides at the end, and I think maybe the best place to begin to address this question If you look at the HFCC document, they address the technical capabilities and opportunities for engagement in experiments. And I know you can't read this, but I added this at a later date, so maybe the slides that you have don't have this yet, but they will. So I encourage you to go to the HFCC document. You see a whole host of areas where US technical capabilities are important for experiments and also in the area of accelerators. I know that we're going to hear from some of the US contributions, and so Tor may want to address this now if he wishes. Maybe he's addressing it in his talk, but anyway, I point you to this document as a place to see more of this information. Maybe it doesn't address the exact question that you asked, which was unique capabilities, but I'll leave that maybe for others more expert to address.
I don't see any further questions. If anyone has a question, we can take raised hands for the next 3 minutes. Otherwise, we might just move on to Gina, who's the next speaker, and Heidi will be chairing that. I don't see any further questions or comments. So thank you very much, Mike.
Yeah,